Hello and welcome to my channel. In this video I am going to demonstrate what is conceptually an easy thing to grasp, but in Unity is actually kind of difficult to fully understand, and that is rotation. As you can see, I have created a little demo scene here, and I can go ahead and move the target around, and the missiles are following, but also the robot is following and pointing at the direction of the target. So this is a pretty simple thing that you can see in a lot of games, but implementing it is actually a little tricky if you have never done so before. So the first thing I want to do is show some code for how to get this target rotating on its own. And I have my own little script here, so I'm just going to demonstrate what it's going to do. So I'll enter in a rotation amount, and this is how much it's going to update the rotation every so often. And to get the target to be like out quite a ways and like rotate around the target, I have parented the actual target to a game object and offset it by -30. So if I click play, this is what's going to be the end result. The target is moving on its own and rotating. So to get that rotation for the target, I made this little script here. And what it does is it has two variables here. One is a private vector3 called additional rotation, and I just set that to the 0 vector. And then there's going to be a public vector called rotate amount, and that's what is exposed in the inspector, and that's just like the amount that you wanted to rotate and how fast and everything per updated frame. So I put that in the fixed update loop so that it will rotate the same amount no matter how fast or how many frames per second the user's computer is running. This if statement here is in here just so I can move the or adjust the position or rotation or anything of the target, so this isn't really super necessary. What is necessary for this here is that the transform.rotation, which the transform.rotation is not a vector3, it is a quaternion. And I don't know exactly what that is, but it's what Unity uses for rotations, and I know it's not a vector3. So what I have to do is take that quaternion, and using its .Euler function, I have to feed it the vector3 of whatever rotation I want it to be, and then that converts it automatically to the quaternion that I want. And then the additional rotation is getting updated by the rotate amount each frame or each time this runs. And then, yeah, so this rotation is being updated by the additional rotation that the rotate amount is being added to. And that is basically how you get just like a simple script of just an object rotating in whatever direction you want. We see here I got -1 in the X, -1 in the Y, and now it's just rotating. I also added a -1 to the Z now, and you can see that it's spinning. Sometimes with rotations and projectiles, you'll get this swarming effect. There's some ways to mitigate that, but I'm not going to go over that in this video. The next thing to look at, I'll reset that back to 0 and 0. The next thing to look at is the missiles from the robot go directly to the target. And in the prefab I made, I have an option for follow player. So if that's checked, then it's going to follow the player. If it's not checked, then it won't. It'll just go straight in whatever direction it was fired. So that's kind of like a heat-seeking missile. I also have some other options here for speed and acceleration. Speed is just the initial speed of the missile. Acceleration will be added on as time goes on. So as it updates, it'll get a little faster. And then aim offset for some targets, it might be useful to add this offset if you know what you're shooting at. And if it's off by like a little bit, then you can like correct it with this value here. Also on the object, I have I'll open it up here. So this is my missile. I have a mesh as a child object and rigid body here. I froze the rotation, set it to continuous, removed gravity, and turned off angular drag. And then I also have a box collider just to detect collisions. So now if we look at the missile script, I have a private rigid body, a public float for speed, acceleration, boolean to follow the player, a private boolean for if the missile can be destroyed and it's set to false by default, the player transform, and the aim offset. So the only things in here that I didn't go over before is this cannot or can be destroyed boolean. And what that is it's just like a little delay that I put in here to delay it from destroying immediately when it's fired, just in case it collides with like the robot's mesh or like another missile's mesh. So yeah, it's just gonna invoke 1/10 of a second after this script starts, and then it'll set it to true. And then when it triggers, if it cannot be destroyed, then it just returns. Otherwise, it'll destroy the object. The player transform is going to be our target. So just in the awake statement, I get the rigid body component and the player transform by using GameObject.find GameObject with tag player.transform. And for this part to work, if I look in here, whatever we're shooting at will need to have that player tag. So for this rotating target, the parent does not have that tag, but the mesh does, because that's what I want to shoot at. And as you can see, the pivot is a little off center of the target. So that's why the missile has that correcting aim offset, just to deal with stuff like that. When we go to the start function, I add a rigid body force with transform.up multiplied by the speed, and I use force mode impulse. The reason I'm using .up is because the model that I'm using is actually kind of off center, or not off center, it's actually rotated in a different way. So yeah, you can see by default I have a 90-degree rotation applied. So the up vector is actually this Y direction here, which is pointing in the direction that we want to go. So that's why I'm using that in this add force statement. Otherwise, there's a ton of other ways you could do this. You could do dot right, one of the axes, that's the red axis, so that might be like the X. You do forward, and that will be maybe the Z direction. But for me, I do up, and that seems to work in this case. Every case is going to be different. So in the fixed update loop, if it is set to follow the player, then I am getting a vector 3 of the direction, which is just going to be the transform.position minus the player position plus an aim offset. So this transform.position is the position of the missile, and you're just subtracting the player position to get a direction, and then adding the aim offset to add any corrections you need. If that's 0, then you don't need that there. Then I need to convert that direction to a rotation. So that I am doing here by defining a new quaternion named rotation, setting it equal to quaternion.lookRotation with the direction as the input. And that's just going to convert it to a quaternion. And then after I did that, I realized I needed to actually adjust the rotation. So just in case, you need to adjust like a quaternion rotation, you could do this, which is, I defined another vector 3, which I called adjusted, because I'm adjusting the angle. And like I said, I needed that 90-degree rotation. So if I want the missile to point at the target while it's going in that direction, then I need to take this quaternion rotation and use the dot Euler angles and add a new vector 3 with the offset that I need, which is just the -90. For performance, I could probably just define another offset variable, but this is fine for now. And then for the actual rotation, I take the transform.rotation and set it equal to quaternion.lerp. And quaternion.lerp is a linear interpolation function for the rotation. So what that means is it'll smoothly rotate from one rotation to another defined rotation. So it's going to lerp from its current rotation to the quaternion rotation from the adjusted angles that we give it. And then this final value is just like how fast it's going to rotate. If you didn't want to do this and you wanted to make it simpler, you could just do transform.rotation equals quaternion.Euler of adjusted. And then in this case, it'll rotate instantly to whatever angle you're setting, or whatever, angle or position or whatever you need. Same thing with this. If you don't need an aim offset or you don't need to adjust anything, you could just do transform.rotation equals quaternion.look rotation for whatever direction you're feeding it. And that's if you already have everything perfect. You worked out your models ahead of time, so they're going to be rotated in the correct default orientation, and you don't need to adjust whatever aim the missile needs to hit the target properly. I'm just going to remove that for now because this is what I need in my case. Your case might be different. Then every frame, I am going to the velocity and setting it equal to transform.up multiplied by speed plus acceleration. And the acceleration I'm increasing by 1% each time. So acceleration multiplied equals 1.01f. This isn't really necessary. I just do it. I'm also clamping it between 0 and 10. I'm just doing it to make it so it speeds up over time, and that can also help with some of that swarming effect too, because if it has a constant velocity, then it's just going to keep spinning. If you add a little, variation in there, then it might course correct itself and hit the target. Either way, that is the missile script. So if we want to go back and check that out, and you see how they're coming out of the different holes for the robot, but they're all hitting the target. That's because they are currently in that heat-seeking mode where they go directly for the target. If I change the prefab and uncheck that box, you'll soon see the ones on the left and right are just going to miss the target. The center one's still going to hit because it's dead center, but they're just going in a straight line now. But if I turn that on, then they will start hitting the target again. All right, and then the last part of this whole thing is the actual robot here. So as you saw, the robot actually has 3 places that it can fire from. So how do you get the missile to spawn here or here or here and actually shoot? How do you get the robot to rotate and point towards the player? How do you get it to not over rotate? This is my solution for that. I've just made a robot script here, and some of the exposed variables here are for the missile prefab, which is this item right here that we just talked about, with the mesh and the missile script, rigid body, box collider. Next item here is the fire points, and it's an array of fire points because I have more than one, and what these are going to be the transform locations where those missiles are going to spawn. And where I put those is in a child object of robot, I have the robot visual. And that actually contains another child object for the mesh and then the 3 fire points. And you can see I just placed them in front of the holes for the object. The reason I did this is because if we rotate the robot visual, I'll rotate that, then I'll select all of our fire points, or I'll just go through them. But you can see they actually moved with the visual. So let's go back to 0. The next thing I have exposed here is a field for the body that we're going to be rotating. And that is just going to be this child robot visual object. And that's actually what's rotating and not the parent or root game object. The next thing we have here is a fire timer. So that's going to be the countdown before another missile is fired. I have a checkbox for following the player. So this guy actually has code to just rotate in circles as well. I have it checked for following the player, and in that way it'll just follow whatever the target is or whatever the player is set to. In this case, it is our target. And rotate amount, that variable is not being used when we're following the player, but that's just like if it's free rotating. And then aim offset, I also have that here. Just because some of my models are not great and they're not centered. So that is just on me. You probably don't need that if your assets are perfect, but it's good for just correcting just in case you need it. So if I pull up the robot script, let's look at some of the private variables I have. I already explained some of the other ones. I have a private int for the fire point index, and then that is going to be used for this array of transforms for those fire points, the places where we do spawn the missile, and that just gets updated each time a missile gets fired so that it goes to a different location for firing a missile. Private float for additional rotation, that is used when we're not following the player. And it's actually these two things here for rotate amount and additional rotation. We could actually probably just take that out because we define that in a different script. So how about I just remove those, and then I can clean up this script even better. And I'll say if we're not following the player, then let's just return. And you can see here in the awake function, we're doing the same search for the player transform. That's another one of our private variables defined up top. And then I have an invoke repeating for the fire missile function starting at 0 time, and then the fire timer is going to be how often it repeats. So in the fire missile code, I have a new game object called missile being instantiated, and we're referencing it with this missile game object. I'm using the missile prefab as the object to instantiate, and then I'm setting the body and the transform of the body of the robot as the parent, just so it gets like the proper scale and rotation initially. But ultimately, we don't want the missile to still be parented to the robot, especially if the robot's going to be rotating, then you don't want it to affect the child object, which would be the missile. So for that reason, I am on the next line setting the parent for the missile to null, and that should just set it to just be on its own root game object. The next thing here is setting the position for the missile, and to do that I am referencing the fire points array at the position of the fire point index and setting it equal to that position. And at that point I'm increasing the fire point index and then doing a check to see if it's greater than or equal to the length of the fire points array. And if it is, then just resetting it back down to 0 so we don't get like a out of array error. All right, and then in fixed update, it's going to be very similar to rotating that missile. So I'm going to get a direction from the middle fire point, which is in this case the second in the array. You could technically just set this to whatever the fire point index is, but I don't think it would rotate fast enough to really matter. So I'm just setting it manually for that one. And then subtracting the player position and adding our aim offset. Again, if this is 0 for you, you don't need that. And if you only have one fire point, you don't need an array. You could just have one transform for the fire point. And then I'm defining a quaternion for rotation, setting it to the look rotation for the direction that we get. And then I had an issue where the robot would look up and then go straight up, and then it wouldn't look good anymore. It'd be at a 90-degree angle from its base. So I wanted to clamp that between maybe like a -45 and a +45-degree angle. So to do that, I made a new vector 3 called clamped, and I'm just setting it equal to rotation.euler-angles. And what I found is actually it's not going to say -45 in this case. It will be instead like the positive value between 180 and 360 degrees. That corresponds to -45 degrees. And there might be a way to handle it with that, but just for my sake, to make it a little easier on myself, I check if the X rotation, which is going to be the rotation when it looks up and looks down for me, if that is greater than 180, then I'm just subtracting 360 from that clamped.x value. And then that clamp.x, I am going to actually clamp the value between -45 and 45. So if it's lower than -45, it's just going to be set to -45. If it's greater than that, then it's going to be set to 45. If it's greater than 45, it's going to be set to 45. And then the last line here is setting the body.transform.rotation equal to a quaternion.lerp function for the new clamped value. So all of this should work together to make it so the robot rotates but doesn't overextend itself in the up and down direction. So yeah, we can take a look at how that works. So I'm just going to go ahead and move this target. And you can see that it's following the player just fine, or following the target just fine. And you can see there is a little bit of a delay there. And of course you could use the other options that we talked about while talking about the missile to make it rotate instantly if that's what you're looking for. So you can see here that we are now pretty much directly over the robot. And it is freaking out a little bit, but it's not looking directly up at the target, which would make this base, if it was completely 90 degrees, it would make the model look bad. Same thing with going down. It's only going to be at a -45, which looks okay. It's not the best, but it's within, I don't know, it's within reason. So anyway, that is the very basics of getting things to rotate in the way you want. There's quite a few ways to actually do it with the different quaternion functions. So you can go back and forth between vector 3s and Euler angles into the quaternions, which I don't think anyone actually understands how they work, but it makes it easy when you can go back and forth without really needing to know what they are or what they do. Anyway, if you like this video, feel free to leave a comment. If you check the description, I will have a link to my GitHub where you can get this sample project. Feel free to use any of the models in the project for free. And yeah, leave a comment on what you would like to see next, or if you have any questions, leave them down below. Thank you. Bye.